Hello, hello. So now we are on to our next step in learning how to factor. So the end goal here is to be able to factor quadratics. So something with squared terms and less than squared terms. Now, eventually we could just use the quadratic formula to get the factors and just kind of back solve to get where we want. And if you are comfortable with the quadratic formula and getting back to the factors that way, by all means do that. You do not have to do it this way. But if factoring is something that makes you uncomfortable, then I recommend practicing the factor by grouping because we're going to use that when we factor the quadratics. So this is all weird little steps that are designed to get us to the end goal. All right, so factor by grouping requires 4 terms, 4 things being added or subtracted. Later on, we're going to learn how to take a standard quadratic that's 3 terms and split the middle term so we have 4 terms, and then we'll be able to do this. So you focus on the first 2 terms, and you're going to factor out whatever their greatest common factor is. Then we will focus on the second 2 terms and factor out whatever their greatest common factor is. So let's start with that, and then we'll see if the leftovers part match. I find that works best if you see it. So 3a minus 6b. All right, well, the a's and the b's are not the same, so that's not coming out. But 3 and 6, I can factor a 3 out of both of those. Now remember, this is coming out multiplication division. So 3 is my greatest common factor. Factor always means multiply. 3 times a would get me back to a, minus 3 times 2 would get me back to minus 6. 2b would get me back to minus 6b. All right, and then our other terms. Now, since this number, this third number is positive, we want to put a plus there. And in fact, I'm going to put it in another color because this particular part goes missing. So when there's a minus, people generally write the minus because they're thinking like factor a negative, but sometimes it'll go missing. The plus will go missing, and then you get kind of confused for what you're supposed to write on the next step. So I'm putting it in green. Don't forget, you should see a plus or a minus in this step right here. All right, back to pink. So we have 2a squared minus 4ab. So let's look at the numbers first. We've got 2 and 4. So both of those are divisible by 2, so I can pull 2 out. And then I have a squared and ab. They both have an a they can donate or undistribute. It's kind of like everybody who has the same thing, they give it all back, whatever those same things are. So in this case, they all had at least 1a, at most 1a. 4ab couldn't give more than 1a, so that's why we're not factoring a squared. So we got 2a coming out, and now we're going to write our leftovers. So I've got the 2, and I've got one of the a's, so the other a will stay, and if we multiplied back to check, 2a times a would be 2a squared, minus 2 times 2 will get us to the 4. I have the a, so I just need the b. So there we go. 3 multiplied to a minus 2b plus 2a multiplied to a minus 2b. Now here's what I want to draw your attention to. When factor by grouping is going to work, those ugly things we got in parentheses have to match. Perfectly identical, the same. When they do match, what we're going to do is factor again, but now we're going to factor those out as the common factor. So how I pulled the 3 out of the 3a minus 6b, I'm now going to pull ugly a minus 2b and a minus 2b out as one term. So each of those terms were divisible by 3. So I wrote the thing out front and put the rest in parentheses, wrote what the leftovers were. Now we're going to do the same thing. So normally, like once you're comfortable with this, it'd be like, all right, here's the thing that was in the parentheses that they both have now, and then the leftovers are 3 plus 2a. which you could then write as 2a plus 3 if you wanted, but that's perfectly fine. Once you have more than one variable, there's not really a prescribed order for how they should go. So here's what I want to do. This crazy thing here, I'm going to call it U for ugly. And like from here to the end of math, that is what U always stands for. Ugly. Whatever the ugly thing is, that's what you should make U. If you're going to go on to take calculus, U for ugly. So, and let me put a note up here. I am defining U to be the same as a minus 2b. Now I don't have to put the parentheses in the equation, but I'm going to put them there because it makes the substitution and back substitution more straightforward. So look at what I wrote now. I have 3u's plus 2au's. Now it should be clearer the same way the two pink terms had a's in them. These two terms have u's in them. So I'm going to factor that u out front. So there's my ugly. And then my leftovers would be 3 plus 2a. So here I traded them out for u's. And now the last step, I would trade it back out for the a minus 2b. And there is our factored form, factor by grouping complete, 2 binomials. So we went from 4 terms to 2 binomials. Magic. Mathemagic. So we are going to do that again and again and again. So the big thing is to see these things in parentheses match, then we know we can continue the process. If they don't match, sometimes it means rearrange the terms. Usually though, if it doesn't work the first time, I'd look for a mistake first, make sure you actually factored the thing correctly, because sometimes people will think, I'm factoring out 3, and then they'd write a minus 3b here instead of a minus 2b. Like my brain almost did that a second ago. It was like, yeah, 3 plus 3 is 6. So totally 3 and 3. Oh wait, no, times, this is times. So watch out for that. It's definitely a thing that should go in the big book of boo-boos. All right, now we're just gonna do it again and again and again. Feel free to pause, try it out, and then come back in and watch me do it and see how you did if you made a mistake. We'll go from there. All right. So I want you to notice here, 6x squared minus 4x minus 15x plus 10. The minus 4x and the minus 15x are like terms. Do not put them together. When it says factor, don't combine like terms. If they give you 4 terms, or if I give you 4 terms, take it as the present it is, factor by grouping, like knee-jerk reaction. 4 terms that I'm factoring, factor by grouping. So this is how our terms, our quadratics are going to look after we split the middle term. So don't combine them back together. We'll leave them this way so we can factor. So 6x squared minus 4x, 6 and the 4 are both divisible by 2. X squared and x can both donate an x. And then we write our leftovers, 2 times 3, and x times x. And we have a minus there. 2 times 2 would get us back to the 4. 2x times minus 2 would be minus 4x. So that is the correct factored form there. And 3x minus 2 have nothing else that could come out, so that's it. Now, this one has a minus sign, so the factoring is going to look a little weirder over here. But I am going to emphasize that in green, just like I did earlier to kind of remind y'all. So 15x plus 10. So originally we're just looking for what number, because they don't have common variables. So 15 and 10 are both divisible by 5. Now because the 15x was negative, the number we have to factor out must be negative. So that way what I write in the parentheses here is going to match what we had over here. So think -5 times what is going to get me back to -15x. -5 times 3 would be -15, and then the x will have to be in here, so it's in that result up there. And now, remember, it's -5. So -5 times what will get us back to +10. So a negative times a negative will get us back to +10. So 3x minus 2. Now, if you ever finish this step and one of the signs is off, double check, like even do the distribution and make sure it can go back. That's the nice thing about the way we do these is the steps are reversible. So you should be able to think, well, if this was my line and I was going to go back to that, does it all check out? But for factoring, now we have ugly. 3x minus 2 is ugly. Ugly up front. 3x minus 2. Leftovers, 2x minus 5. And sometimes I like to double check. 2x times 3x would be 6x squared. -2 times -5 will be +10. So the outer and the inners should match as well. I don't like doing the whole thing because I'm lazy, but that's at least a quick check. You could fully multiply them back out and you should be able to get back to those 4 terms when you do so. But this is the factored form. Now, I noticed in the quiz, some of y'all were taking things like this and then setting them equal to 0 and solving. This didn't start with an equal sign. So if it doesn't start with an equal sign, you cannot solve it. You can't just throw it in there. I know some teachers would just kind of do that randomly, especially when we're looking at functions and how to graph them. We are going to choose to set something equal to 0, but it's because what we start with is an equation. Like a function will say f of x equals, or a graph will say y equals. It starts with an equation, so we can put 0 in place of a variable. Here, though, not an equation. All we can do is factor. All right. Let's take a look at 17 in all its craziness. So 18a cubed b minus 9a squared b squared minus 2a plus b. So you might notice the second terms, the last 2 terms here, don't have much in common. That happens sometimes. You're going to see why in a second. All right. I picked all of these for deliberate reasons back when I wrote the notes. So our first 2 crazy terms, 18 and 9. Well, I can pull out a 9. And sometimes I like to actually, apologies, I should take the trash out. I'm not going to. I like to actually write what at least the first number would be, just to kind of remind myself. 9 times 2, back to 18. Okay. A cubed and a squared. They could both give back a squared. And a b squared, they could both give back 1b. So with the 2, 9 times 2 is 18. A squared times the leftover a. Hold on, I know what's wrong. All right, hopefully now it'll work better. I moved it closer. All right, so 2a, and then this has a minus, so we are going to see a minus here. I have the 9, the a squared, and one of the b's, so all I get there is a b. Now I want you to take a look. 2a minus b minus 2a plus b, like it's almost the same, except the signs are opposite. But remember earlier when we had that minus sign on the third term and I said we have to factor out a minus, that is what we're going to factor out. So we're going to have that minus here, that green minus. Now, 2a and b don't actually have anything in common, but there is always a number that we can multiply by that doesn't change things. So here we're going to use that number as the multiplicative placeholder, which is a 1. So I can always multiply by 1 or a crazy form of 1. I can always add 0 or add a crazy form of 0. That's like one of the weird math tricks we're going to see pop up over and over again. Now here, since it's a -1, we have to change the signs for it to multiply back. So -1 times 2a would be -2a. So that is now correct. -1 times -b or -b would get us back to +b. And now uglies match. So ugly up front, 2a minus b, and 9a squared b minus 1. Now, some of y'all may have looked at this and didn't like the way the second part was looking, so you swapped the middle two terms. That's totally fine. You can do that. And you'll get the same answer. You'll just get them swapped, which is totally fine. And Alex will take the answers either way. I might have problems if I have you guys type an answer like this for the midterm, but I can go in and adjust grades. So if you're worried about your answer not coming out correct, wait for me to grade it and then bring it to my attention if you think I missed it. Because I have that power, at least for 1311. All righty, now 18. Woo, we're just moving along. So this one has a lot going on. So I want you to look what is weird about this one. It's a little bit different than the others. It has something unique. So I want you to think about it for a sec. All right, so hopefully you thought about it, or you can pause. But the weird thing is that all of these terms are actually divisible by 3. This happens sometimes in our quadratics even as well. Like all the terms will be multiplied by 2 or 4 or 5, whatever, or 10. Like when that happens, we're going to want to factor that term out to the very front. So this is one of the cases where when it says factor completely, this is one of the extra steps we have to take. For what we're doing here, we could factor it out at the beginning, or we can factor it out at the end. I usually prefer, when I notice it at the beginning, to factor it in the beginning, because then the rest of the numbers will be smaller. Thus, less mistakes with factoring, hopefully. Now, writing that, though, is going to look a little weird, because we have in between steps with parentheses, but now I'm going to have an outer big set with just a number hanging up front, or whatever the common term for all 4 is. So for that, I'm going to write that down, and then I am going to go with brackets, just so it looks different from the parentheses. But I am going to rewrite this every step until we get to the end. So it can be a little tedious, but you don't want to forget it. So sometimes I like circle it and I draw a squiggly arrow and then I write it at the bottom of my work to be like, don't forget, you should see a 3. All right, so when we factor that 3 out, this is now 2x squared y plus 2x squared plus 3y cubed plus 3y squared. Ooh, smaller numbers. And again, 3 bracket. 2 terms. Well, they both have 2's and x squareds. I'm going to have to write that further. All right, so we have 2x squared. My leftover will be the y plus, and now this one is also here because all of this is factoring out. So it's really tempting to be like, oh, it's just a y. But if you multiplied that back, you'd only get the first term. You wouldn't have the 2x squared. So what do I have to write here that I multiply 2x squared by so I get 2x squared after the distribution? I need that placeholder number again. So we're going to see a 1 here. So this is what it looks like when you're going to see the 1 inside the binomial. The previous example was what it looks like when you see the 1 in between the 2 binomials. two terms in a parentheses is a binomial. All right, and now same song, second verse. Positive. Definitely have a 3, and they can both donate a y squared. Just a y, and again, everything came out, so we need a 1 as a placeholder. Yay, colors! If any of y'all are colorblind, please send me a private email. I can try to talk colors more if that's the case. All right. So we have ugly and ugly as the y plus 1. But before I forget, the 3 and the brackets. So y plus 1. And then I have 2x squared. The y plus 1 is up front. Plus the y plus 1 is up front. So 3y squared. And we close it. All right, now look at this line. Do I need the brackets? The line before and the line before that, I needed them. On the middle two lines, I need those brackets. But on this last line, I no longer need the brackets. I say this because Alex sometimes gets finicky and it might get confused if you have multiple sets of parentheses. For sure, do not type brackets. Brackets in later math mean different things, and in programming they mean different things. So if you put them in, like, Alex might freak out because it thinks it should be something else. But here, we don't even need them at all. We wouldn't need a second set of parentheses around here because multiplying these two and then multiplying by 3, the order I do that in doesn't matter. So our final answer, we're just going to have that 3 hanging out up front, the y plus 1, and the 2x squared plus 3y squared. That would be our final answer. If you do not factor the 3 out, Alex will get grumpy and it will tell you, this isn't fully factored. That's almost always what they mean. What it would look like if we didn't factor the 3 out at the beginning is we'd either see 3y plus 3 here, or we would see 6x squared plus 9y squared. We'd probably see that actually, because that's like factoring out the most, that's where it would end up. Those extra numbers can cause us problems with some of the other ways we can organize our factoring terms, so be on the lookout for them. When everything is divisible by the same thing, pull it out as soon as you can if you're going to have to factor, or even if it's an equation you're going to have to solve, because you can split it out real quick. All right, last one is just this idea of fractions. I know I said the F word. So here, this is the idea of, I have fractions in this ugly mess. I don't want to factor or do the quadratic formula or anything with fractions. No, thank you. But, well, this isn't even an equation, so I couldn't use the quadratic formula technically. But for sure, I don't want to do anything with fractions. Yuck, no. So we can factor the fraction out as a common term. And even if it wasn't common in all of them, we could still factor it out, and we just have to make one of the numbers larger to compensate. So that 1/3 coming out front. And I think I originally put this down because the program we were using at the time actually would ask questions where they made you do this. And so I wanted to make sure I had an example, because it can be a little awkward if you don't understand what they're asking. So when I pulled the 1/3 out, remember this is multiplication. So what would I multiply 4/3 by? What would I multiply 1/3 by to get back to 4/3? So 4/3, you can think of it as the same as 4 1/3. So 1/3 times 4 would give us 4/3. So just the 1/3, and then we still have the h squared. Now we do it again. 2/3 times h. So 2/3. The third is out front, so we just have a 2. Plus 1/3 times 1 would get us back to 1/3. That's all they want. Especially for here, we haven't even talked about factoring a 3-term quadratic yet. If all they say is factor out this fraction from the mess, just factor it out and write the result. Don't do more work than they ask for. All right, so that is the end of this video. As you can see at the bottom, we are going to factor those 3-term ones now, but our front number is going to be 1. We're not going to factor with number in front of there yet. We'll get to that 2 videos from now.